All right, IBSL1. Today we're going to start the back half of Chapter 3, starting with 3.4, and we're going to start talking a lot more about parabolas. I realized we did parabolas a little bit in the beginning of Chapter 3, but that was really more a focus on transformation. Today we're just going to focus on all parabolas, the different forms that they have, and graphing them without a graphing calculator. So the first form we're going to focus on is vertex form. Now, vertex form, I would almost call transformational form because it looks very similar to the transformations we just did, where this H inside is your horizontal shift and the K outside is your vertical shift. The A is your vertical stretch. These are things that we covered in transformations, so we're just going to jump right into sketching some of these or talking about the features of each parabola. So, first thing, if you look at a parabola, there's this line that goes right down the middle of it, and this is called the axis of symmetry. And it's an x equals axis of symmetry. So like x equals -3 would be an axis of symmetry. The other thing we need to label on this is that the very top of the mountain or the very bottom of the valley is called the vertex. And that vertex is in the form h, k. Now, at the axis of symmetry, I really should have said that the axis of symmetry is the x equals the x value that it spins around on that vertical line. So if you know that the vertex is in the form h, k, the axis of symmetry, so we'll call that the axis of sim, is x equals h. So for these two problems here, these two examples, I'm going to show you guys how to just take an equation and state the vertex and the axis of symmetry. So when I look at this first example, I see that it's been shifted to the right 4 and up 1. Now, to find the vertex, I don't care about the a value. I don't care that it's upside down. I don't care that it's been vertically stretched. You can just say that the vertex is +4, 1. So you kind of have to switch that number that's inside the parentheses, but we already know that because horizontal translations are backwards of what they should be. The axis of symmetry is x equals 4. It's just those, it's just the x value of the vertex. So x equals 4 is where you can leave it. The second problem, let me scoot that up a little bit. The second problem, the vertex, once again, is just the transformational shift. So it got shifted to -3, -6, and then the axis is x is equal to -3. Now for a little U-try. Please find the vertex and axis of symmetry of that equation right there. All right, there's your vertex and axis of symmetry. Next up, we're going to talk about general form. So general form, there's nothing factored about it. It's just ax squared plus bx plus c. All of these say a does not equal 0 because that would be a very boring parabola if the a was equal to 0 because it would just be a line. It would be a linear equation. Now, if you're given general form, the axis of symmetry is -b/2a. You might recognize that -b/2a as part of the quadratic formula, which is true, and we'll get to the quadratic formula eventually, but right now we're just going to say the axis of symmetry is x equals -b/2a. The coordinate of the vertex. Now, I realize this looks insane, that it's so complicated, but really if you think about it, it's not. The x equals -b/2a is just some number. So the vertex, the x value of the vertex is just the axis of symmetry, so it's -b/2a. Now, f of -b/2a is just feeding -b/2a into the original function. So it's putting it in for x into these spots here and then crunching out what the y value is. The y-intercept is just c, which makes sense because if you were to replace x with 0, that would get rid of this part and leave you just with a c value. All right, first example, we're going to sketch a graph, label the vertex, axis of symmetry, and the y-intercept. So we're going to start with negative x squared plus 6x minus 4. Well, first I'm going to use the x equals negative b over 2a trick to figure out what the axis of symmetry is. So b, like here, a is equal to negative 1, b is equal to 6, and c is equal to negative 4. So negative b over 2a is negative 6 over 2 times negative 1, which reduces down to 3. So if I go over 1, 2, 3 tick marks, that means my axis of symmetry here is x is equal to 3. Now, I know the vertex is on that line somewhere, so all I have to do is put 3 into the function. So we get negative 3 squared plus 6 times 3, take away 4. Now, when you do that, I believe you get 5. So f of 3 is 5, which means that the vertex is 3, 5. So if I go to 3 and then I go up 1, 2, 3, 4, 5, that means here is our vertex at 3, 5. That's a 5. Didn't really make it better. Okay, that's 3, 5. Now, it doesn't say that we have to do x-intercepts or anything like that, oh, we do have to find the y-intercept. I forgot. It said in the directions. So we have to label the vertex, the axis of symmetry, which I've already labeled both of those, but we do need the y-intercept. Now, you guys, the y-intercept is just that number on the end of the equation, because if you make x 0, it gets rid of everything else. So y-intercept is 0, negative 4. So that means if I go down to 1, 2, 3, 4 right here. So my parabola will go like this and like this. There's the sketch. Axis of symmetry, vertex, y-intercept. Let me do one more for you. Same directions. We're going to find axis of symmetry, vertex, and y-intercept. So if I use x is equal to negative b over 2a, we get negative 4 over 2 times 2, which is negative 1. So the axis of symmetry, x is equal to negative 1. So if I put dots here on negative 1, this is x is equal to negative 1. Now, to find the vertex, I need to put that negative 1 into the function. So we get 2 times negative 1 squared plus 4 times negative 1 minus 1. Now, if I crunch that out, I believe that's negative 3. So we get f of negative 1 is equal to negative 3. So vertex is negative 1, negative 3. So if I go down 1, 2, 3, here's my vertex. Then y-intercept, once again, is feeding in a 0 for x, but then it's really just going to be this number on the end here. So the y-intercept is 0, negative 1. So 0, negative 1, that means that it hits right here, which means it must be a parabola that opens upwards, which we kind of knew from this a value being positive. It looks something like this. Oh, I didn't label my vertex. Hold on. It's negative 1, negative 3. And the y-intercept is 0, negative 1. I think I forgot that on the last one. I should have labeled my y-intercept, which was 0, negative 4. All right, your turn. Sketch a graph with the axis of symmetry, vertex, and y-intercept labeled of that. right, you guys, axis of symmetry was 4, the vertex was 4, negative 11, and the y-intercept was 5. Factorized form. Factorized form is a times the quantity of x minus p times x minus q. So notice it's been factored into parentheses, and once again, a cannot equal 0 because that's very boring. Another way that this is called sometimes is intercept form. If it's in that form, if you switch the p and the q values, you get your x-intercepts. This is where it crosses the x-axis. So that means that the axis of symmetry is x equals p plus q divided by 2. Now, that makes sense because if you think of this intercept as being p and this intercept as being q, or you could put them in coordinate form and say this is p comma 0 and this is q comma 0. The line directly in between them is going to be the halfway point between them. Now, how do you find a halfway point? The axis of symmetry, you average them. So to average two things, you add them together and divide by 2. So the axis of symmetry is p plus q divided by 2. Then, once you have the axis of symmetry, it is very similar to the last form we were doing to find the vertex, that you take the axis of symmetry and feed it into the function to see what you get out of it. Let's take it for a spin. Find the axis of symmetry, coordinates of x-intercepts, the y-intercept, and the vertex. Sketch the graph. Well, I can spot the intercepts right off the bat. So the x-intercepts are negative 3, 0, and negative 1, 0. That means the axis of symmetry is going to be x equals negative 3 plus negative 1, all divided by 2. We're averaging the x-intercepts. So this is negative 2, because you get negative 4 over 2, which is negative 2. So axis of symmetry is at negative 2. The x-intercepts are negative 3, 0, and negative 1, 0. Then to find the vertex, we need to do f of negative 2. So replacing the x values with negative 2. And then this is, which one are we doing? Positive 2, when you work that all out. So that means that our vertex is at negative 2, positive 2. Let me see, what else did I have to do? Axis of symmetry, coordinates of the x-intercepts. Oh, I didn't do the y-intercept. To find a y-intercept of any function, really, you just make x 0. So you get negative 2, 0 plus 3, 0 plus 1, which is negative 6. So 0, negative 6 is the y-intercept. So it looks something like this. You try. Do everything I just did with x minus 4 and x minus 2. So find the axis of symmetry, the vertex, and the y-intercept. All right, you guys, the axis of symmetry was 3, the vertex was 3, -1, the x-intercepts were 2, 0, and 4, 0, and then the y-intercept was 0, 8. All right, good luck.